All right. Good morning, everybody. Happy Thursday. Thank you for joining us today for our 9th tech webinar this year. My name is Anthony Connors. I'm the regional field engineer for the Michigan and Toledo area. I'm going to be your host for today. Let's go over a couple things here quickly. You might be noticing if you're new to these type of live events. I'm sure you've already noticed this, but your camera and microphone have been turned off. And hopefully on the right side of your screen, you should be seeing a Q&A feature. If you have any questions that come up during the presentation, you can feel free to submit them there with your first and last name as the presentation is going on, and we're going to take some time at the end to answer your questions. If for some reason that doesn't seem to be functioning for you or you can't find it, you can always email your questions to solutions.michigan@swagelok.com, and we'll add your list and we'll add your question into the list for our presenter. But with that out of the way, I would now like to welcome Steve Burkowski for joining us today. Steve has spent many years with our Swagelok team. He's currently serving as our construction specialist. Steve focuses on our customers with larger projects or construction projects and has a lot of experience with finding the parts and tools necessary to complete the jobs. So without further ado, I'll now turn it over to Steve.
Good morning, and thanks, Anthony. If you've listened to one of our webinars in the past, then you know that we always start with the what, the when, and the why. So today we're going to cover what tools are available, when would you want to use them, and why would you want to use them. To get started, we'll cover a variety of hand tools that make your job more accurate and easier to accomplish. A hand tube bender is a nice tool to bend the tubing and reduce the number of fittings that you have in the system. Tube cutter comes in handy for cutting the tubing. A hacksaw is another option for cutting the tubing, but we do recommend using a tube cutting guide. And a tube deburring tool is going to be needed so that you can deburr the ID and the OD of the tubing. We'll go over a couple other tools too after we finish those. Let's start with the hand tube bender. A tube bender allows you to bend the tubing instead of using tube fittings. You'll want to use the hand bender for any offsets or 90s that you have. If you can reduce the number of 90s in the system, then you've reduced the number of leak points, as well as improve the flow characteristics of the system. Hand tube benders are available in fractional metric sizes, 1/8 inch to 1/2 inch. Now, a couple of features to look for too, if you are using a hand bender, is it's really nice to have a hand bender that can be mounted in a vise or clamped in there. This is going to allow you some extra support and the ability to use both of your hands instead of one. Roller dies are another nice feature too. They help to reduce the bending force and maintain tube ovality as compared to the conventional slide block designs that you see on other benders. Those will tend to flatten the tube and reduce flow. The clevis handle too is very nice. If you look at the short handle on there, you can unthread that handle, kick it up 90 degrees, tighten it back down, and then it allows you to make bends that are greater than 90 degrees. So if you're making that 180 or something, you're not crossing your hands over one another. A good tube cutter is essential too. Like when you're cutting soft copper or aluminum, it's relatively easy, but the harder stainless steel can present more of a challenge. You want a good quality cutting wheel. Twin rollers are going to allow for nice smooth rotation around the tubing, and a fatter handle is going to make it a little bit easier to advance the tube cutter wheel. So when you go to cut the tubing, all that's really necessary is just position the tubing in between the rollers and the cutting wheel. Then you want to advance the cutting wheel in until it touches the tubing, and then rotate the cutter around the tubing or rock it back and forth. Try to get a couple of revolutions in each time, and then advance the wheel another a 1/16 of a turn into the material. Be sure that you just don't rush this process though, because if you do, you're going to shorten the life of the cutting wheel, or you could risk damaging it or breaking it. The second hand tool for properly cutting tubing is a hacksaw. To ensure the tube end is cut squarely, we just suggest that you use a tube sawing guide. The tube sawing guide fits right into a vise right there, and then it allows you to use a hacksaw or even a portaband to just make a nice square cut. It's going to hold the tubing as well as give you the square cut that you're looking for. During the cutting process, the tube cutters push burrs into the ID of the tube, and hacksaws are going to burr both the ID and the OD of the tube. But regardless of which method is used to cut the tube, these burrs have to be removed. Deburring is important for proper fitting function as well as for clean, leak-free systems. ID burrs can break off and cause damage to components and other parts of the system by lodging in the small holes or vents, or by scratching valve seats or soft seals such as O-rings. To deburr the tubing, you just want to do the inside diameter there first, slide the tool into the ID of the tubing, rotate it around just back and forth a couple of times, then flip the tool over, and on the other side is the deburring tool to do the outside diameter. Same process there, just twist the tubing around. If you look at these two examples right here, you can see that the one is, it shows the tubing on the left has been cut with a tube cutter, and the tubing on the right has been cut with a hacksaw. And you can see the difference in the two, where the tube cutter you don't get any burrs on the ID of that one. It tends to kind of push out, and the hacksaw, you're going to end up with burrs on the ID and the OD. So your tube cuts with the tube cutter is going to be smooth, or may show some light concentric lines. Those burrs are only going to be on the ID, like I said, and then tube cuts with the hacksaw are going to be rough, leave parallel lines running along the edge that could exhibit some burrs on both the ID and the OD. We do have some additional tools then to make the job easier. A gap inspection gauge is available. This tool slides between the fitting nut and the body, and it allows you to check for sufficient tightness, or if you pulled the fitting up enough. Did you go the true 1 1/4 turns? It's a go, no go gauge. If it doesn't fit in, then you have done it correctly. A pre-swaging tool is used to pre-swage the nuts and ferrules onto the tubing. So maybe you want to pre-swage them on the bench and then take it over to your piece of equipment and install it. T-wrench is available to hold onto T's. This works out a lot better than using a crescent wrench. It just gives you a lot of support to pull up the fitting there. A ratchet wrench is made to pull up tube fittings, fits around the nut on the fitting and allows you to tighten it. And a depth marking tool is available to make sure that you've bottomed the tubing out inside of the fitting. You take the depth marking tool, you insert the tubing, you mark a line at the top of the nut and the tubing. Then when you go to put it into the tube fitting itself, you should not see the line. And that would mean that you're bottomed out in the fitting and on the shoulder. Then we do have a nice little tool case here. It's a Pelican case. It's watertight, can be locked, holds all of your cutters, benders, T-wrenches, and ratchet wrenches in there, your deburring tools. It's kind of a nice way to just sort of keep everything organized and in one place. I've been on a lot of job sites where all of these kinds of tools tend to never make it back to the shop. They grow legs and walk away. So it's kind of nice to make sure you keep them all in one spot here. Then we do offer some specialty equipment. So if the hand tools, something a little bit above that, a little more than hand tools, get you into these specialized pieces of equipment. An Orbital weld system is designed to weld stainless steel tubing. A multi-head swaging tool is designed to pre-swage the nuts and ferrules on the tubing. And then we have a benchtop bender and a large tube bender that will bend up to 2 inch in size. The M200 power supply, it produces a reliable, consistent orbital gas tungsten arc weld. It's going to plug into a standard 110 outlet. It uses no filler material and just joins the two parent materials together. This is commonly used to install high purity gas systems, pharmaceuticals, emissions, testing, and paint lines. It's a fully automated system with a 12-inch color touchscreen. You just input the material that you're welding, the size and the wall thickness, and then the machine generates a weld schedule. Now we have several weld heads that are available or that match up to the welder. There's a Series 4, which is like our micro weld heads, and the 8, they have a flexible head on them so they can get into those tight spots. A A Series 8 production head is our high production head if you're just doing some bench mount, knocking out the same weld one after another. And then we have the 520 and the 40 series head. These are the most popular heads that we use. And by changing side plates and stuff, we can get into a lot of different configurations of valves or shorter tangent lengths. The shortest tangent length that we can do with a 5 or a 20 is going to be 1/4 of an inch. And the shortest, it's going to be 1/4 of an inch with all of them. It's 1/4 of an inch. And the weld system itself is capable of welding 1/16 inch through 4-inch tubing and 1/4 inch through 4-inch pipe. If you look at this picture here, I have a short little video that I'm going to share with you guys. It shows how the weld system works and gives you kind of a live action shot of a weld actually being made. You can see the power supply in the background. We have a purge that's going on right now where we're purging the inside diameter of the tubing. And in a minute, you will see an arc stripe down here. If you look up to the right too, you can see a circle on the screen that just lit up and started moving around. That is real time of what the electrode is doing inside of there in welding. So it looks like it went around and it made 4 tacks on the tubing, and now it's gone back to the home position and has initiated the arc and started a weld. And it's traveling around. You can see a little light flickering in there, but the really kind of the nice thing about this is that it's all self-contained inside of there in an inner environment, and you don't have to wear any type of eye protection or anything like that when you're using the tool. So this is what it looks like before we would make the weld, where we've joined up the 2 pieces on the left. We've hooked up a purge to the ID of it, which is going to run argon through there to give us a nice inert environment. It's going to cool the weld, and it's going to help to hold the weld puddle up as it makes the weld. And then on the right hand side, we're going to put another fitting on there, and that's going to be used as a restrictor so that we maintain a little bit of pressure inside of that tubing as we weld. Then on the right hand side, you can see with the weld head off of what it looks like after it's been joined together. Now, the multi-head swaging unit is another tool. This pre-swages the ferrules onto the tubing. It just places no initial strain on the fitting body threads and just reduces your installation time and the chance of having operator error. The MHSU must be used to install fittings over 1 inch, but it's also available in sizes down to 1/2 inch. The benchtop bender is a nice little bender. It helps to pick up that space where the hand tube bender leaves off, which is 1/2 inch and above. So it picks up that 3/4 inch spot right there. This one can bend from 1/2 inch up to 1.25 inches. You can mount it on the bench or stick it on the optional tripod that you see in the picture right there. Then it has a crank on it with 3 different speeds that you can just turn around and make your bends. Then the other bender on the left is our large tube bender. That one bends 1 inch up to 2 inch. And it does tubing in 1 degree to 110 degree increments. Now, as well as having physical tools of hand tools and some of our specialty tools, we also have an online toolbox. Michigan.swagelok.com is an online resource for finding, quoting, and purchasing products. There's CAD files, sales drawings, technical videos, product specs, and certifications that can all be found here. There's also a CV calculator and a regulator flow curve generator. The CAD files, we have over 1 million of them that are there. They're in 2D, 3D format, and they're in basic formats, or several different formats that will match up to your particular CAD software that you have. And when you are selecting the CAD files, you can answer some of the questions that are on here and search by specific criteria. If you're looking for male or female pipe, if you want an air actuator on it, if you need a different color handle, anything like that. It's all you can select going through there. Just remember that when you are doing that, if you don't find the exact part number that you're after, just go with something that's close. So maybe a 40 series valve in itself, and it has tube fitting ends, but it doesn't have the actuator, it doesn't have the special lube or special seats or seals that you're looking for. It's still going to be your same basic footprint and can be put into the model so that you get something put in there. If you do have a problem and you can't find something, then please just reach out to us and we'll be happy to help you with it. The CV calculator, it's used to size a valve in your system. Valves typically have a smaller orifice than the tubing that they're connected to. So you got to make sure that you have enough flow capacity with your valve selection. So by plugging in a few criteria on here, like if you're looking for the CV or the flow coefficient, and then if you want the flow, the medium type, do you want gas, liquid, your inlet pressure, your outlet pressure, and then whatever temperature that you're at. And then same thing for the system media. It's going to pick a specific gravity out of the media. So if your specific gas is not on there, then just select something that's close so that you do get the gravity that's close. The regulator flow curve generator does exactly that. It produces a gas flow curve to aid you in selecting the correct regulator. So earlier this year, we hosted a webinar that goes into greater detail, but basically it's going to help you avoid some of the pitfalls that you'll have in selecting a regulator. Things like lockup, choked flow, or excessive droop. Just remember though, it is important to note that this tool, it only works on the RHPS regulators. So these are regulators that go 1/2 inch through 6 inch in size, and they are intended pretty much for high flow bulk gas type applications. Services too. We also have a host of services where we do equipment rentals. We can do benders, orbital welding, the MHSU. We have construction support too, where we come out on site. We can do vendor managed inventories, product selection, submittal packages, and installation training for you. We also make custom fabrications and assemblies where we can take components used on the project, assemble them, provide a plug and play system just to speed up the installation and reduce ordering. And then we have some field engineering services too, where we come on site and assist to identify leaks, evaluate, design risk, and optimize fluid and sampling systems. So when we started out here, we said that we were going to talk about the what, the when, and the why. So the what tools are available to make the job easier. We have hand tools like benders. We have specialty tools like the Orbital Weld machine, the MHSU, some online tools like the CV calculator and the CAD file downloads that can be found. And then we also offer some services too, like vendor managed inventory and engineering services on site. The win, anytime you have a stainless project involving a gas or a liquid system, please feel free to reach out to us. The sooner the better. We can help in product selection and just make the job go a lot smoother. And why? So we can end up with nice, safe, efficient systems. So that's all we have for the presentation then. Anthony, did we have any questions that came in?
Yeah, great job, Steve. We got a bunch of questions here coming in. Real quick, it sounds like I'm getting some feedback on your side, Steve, when I'm talking here. And looks like we fixed it. Perfect. Awesome. Okay. Yes, so we got a couple questions here. We're gonna go ahead and get started with. I do want to remind everybody that if you do have a question, you can submit it with the Q&A feature on the right side, and we'll add it to our list here. But just diving right in, first question here is from Jared, and Jared's asking, I have some 3/4 inch tubing I need to route. Do you recommend bending or trying to use elbows?
That's a good question. And this would be a great opportunity to use our benchtop bender, the one that kind of picks up after our 1/2 inch bender. It's a nice, easy, portable machine, and it would be great to reduce some of the fittings in the system. If you could use that bender, great. Sometimes you do have to use actual fittings and put 90 in there because you don't have the space required, or it gets a little too tight in some places. But if you can, yes, and we do offer a rental of that bender.
Yeah, great. Okay. Moving on here. Next question is from Tom, and Tom is asking, sometimes we need connections with orbital welding, but not often enough to get somebody trained. Is this something you can do?
Yeah, it is something that we can do. We can do orbital welds and build little spool pieces or assemblies and stuff here in our shop. The only thing that we do ask is that you get us involved early in the process because we want to ensure that we select the right components. We want to make sure that we have wall thicknesses that match up and we have tangent lengths or tube stubs that are long enough that we can get them into the fixture block and make a weld. One of the benefits, though, of having us do it too is that you're going to end up with all the paperwork and required documentation that you need for the weld. We can do leak tests on it. We can do helium leak testing, and we can provide all of the weld coupons, certifications, and material certs that you would need, and you'd be all ready to go.
Yeah, great. Thanks, Steve. Next, we have a couple questions from Ernesto, and it sounds like first thing is sounded like he wasn't able to stay for the full presentation. I just want to know if there was going to be a recording of it. So I just want to make sure that everybody knows that yes, this is being recorded. The recording is going to be sent out with the link and the links for some of the tools to everybody that registered tomorrow. So look forward to that in your inbox tomorrow. And then Ernesto also asked, is the welding system able to work out in the field? So I know that the welder needs at least, I think it's 120 to 230 volts to power on. And then you also need access to some sort of purging gas, right? Like some argon or something. Is there anything else you need out in the field to run that M200, Steve?
Yeah, you're right in saying that, Anthony. It runs off from just a 110 plug, a standard outlet you can plug it into and run. One of the nice things is that it is portable. It only weighs about 50 pounds. It's easy to carry it around. We do make lots of different extension lengths or cables for the weld heads. So you can get up to about, I think it's about 75 feet away from the machine itself with a weld head. So it's portable. You can put it on a man lift, put it up in the air, leave it on the ground, take the weld head up, whatever you're looking to do, but certainly take it out in the field.
Yeah, great. All right. Moving on here. Next question is from Phil, and Phil is asking, if I only have one or two fittings over 1 inch, can I just tighten it by a wrench?
Oh, it's a question that we get often then. The short answer is no. I would not recommend it at all. When you get over 1 inch, it is mandatory that you use the hydraulic swaging unit to pull up those fittings. And the reason really is that it's just so much torque and strain that you're going to put on the fitting threads and the body and stuff itself and on the nut. It's just not worth it. I mean, you could take a monster cheater wrench and try to get that thing tightened up and you're going to have problems. I guarantee it. So go with the MHSU. It reduces all that strain and stress on the fittings. You're not going to gull the threads and you're going to have a nice leak-free connection.
Yeah, excellent. Next one is a pre-submitted question we had from somebody signing up from Steve F. And he's looking for some compound bending tips.
Okay, so I'm going to assume that compound bending is like making bends or multiple bends like in a different plane. So instead of it just being flat, we're going up and then maybe over and then back down type of thing. And we certainly could help out with that. We do offer a training class where we do bending essentials that is just a half-day class, and it addresses all of those questions right there and gives you a lot of good tips because we do a bunch of bends that go in and out of a box, and it's like a real life situation that you're trying to make the bend. So be a good opportunity to try the class.
Yeah, excellent. And then actually next question kind of goes along with that. Zach's asking, do you offer training classes for bending 1 inch and 1.5 inch tubing?
Well, currently we do our bending essentials, which only works on the smaller sizes, less than 1 inch, but the principles transfer right over. And we would be happy to do a advanced bending class where you could take the skills and stuff that you've learned in the first class and transfer them over using a benchtop bender or the large tube bender.
All right. Thanks, Steve. And that takes us to the end of the questions here. Thank you, everybody who submitted a question here. And as always, if you have something that comes up after the presentation, you can always email us and we'll reach out. And yeah, but so following up here, after here, you'll be receiving some of the reference materials listed here, some of the CAD templates and sales drawings, and then a couple of useful how-to videos for bench topping, and then also just some information on our equipment rental services in case you're looking to just use a job real quickly without actually having to make the purchase of a full piece of equipment here. And always we do ask, if you have any sort of needs for it, you can always schedule a virtual meeting with our field engineering team at michigan.swagelok.com. And coming up next, so next webinar will be December 9th at this year at 10 a.m. again. And it's going to be a kind of an open format where you can ask us any sort of questions on your fluid systems, and we're going to have our engineers on the call to hopefully help you out and get you where you need to go for your issues. So December 9th, so a couple months from now at 10 a.m. And again, for any questions, concerns, or feedback with the webinar, you can always email us at solutions.michigan@swagelok.com. And I want to thank you all for joining us today. And for more information about our webinars, you can view our website at michigan.swagelok.com. Thank you, everybody who joined on today and you sent us some questions, and have a great rest of the day.